Hey there. Welcome everyone to the latest webinar, which is the part one of a two-part series on the topic of lighting and HVACD decisions in planning a new build. We will be hosting a retrofit session in August, but today we're going to be focusing on new build planning. So my name is Casey, and I started out in the medical world in Arizona and moved to Oregon back in 2014 and started a medical farm that went recreational farm and then built a few more. And now I get the pleasure to work with Fluence, helping the business development team on a larger global scale. So before we dive into this agenda, I would like to go through a few housekeeping items. This webinar is being recorded and it will be available to you on the website tomorrow. We encourage you to ask questions. Take a look at your footer down below and you'll find the Q&A button. So please feel free to ask questions using this function and our panelists will answer at the end of the session. So before we get started, I would like to set the stage for what to expect today. First and foremost, we would like to acknowledge that there are many decisions you have to make when planning a new facility. And today we are here to talk to you about lighting and HVACD specifically and the relationship between the two. We recognize if smart decisions regarding these two technologies are made up front, you will save yourself from significant frustrations and loss of revenue down the line. So this prevention will break apart the key performance analysis all new build facilities should be leveraging when making decisions and planning with different manufacturers. This analysis will also show you the impact lighting has on your HVACD system and sizing and how these decisions impact not only your CapEx, but also your operating expenses too. So now let's go on to the agenda. Today we'll be starting by detailing a checklist all new builders can reference when beginning a design. Then we will discuss the critical inputs of the key performance analysis. But before we show you the good stuff, you will hear from Fluence regarding key lighting terms and metrics. Then we're going to join the Inspire team to help us define key terms and metrics relevant to HVACD planning. We will do a quick review of yet another tactical checklist you can apply to making your manufacturing decisions. And we will end by running through two case studies by using the key performance analysis tool. So we thought this would be a great opportunity to run through a high-level checklist that encompasses overall new build facility planning. So I myself have started several grows here in the Pacific Northwest, and combined with the knowledge Inspire has in Fluence, this checklist should cover basics of what you as a facility designer should be doing. Now again, these are only recommendations, but you can take this and apply it directly to your business and your business model and goals. So the first step is define your business goals. So knowing and understanding your business goals and establishing your budget and timeline is a very important step. And this of course goes without saying. Budget and timing are critical to understand before you make your decision on purposes or on your purchase decisions. Understanding your business goal and aligning your purchases and your design plan based on what you're trying to achieve is very important. Next step is to secure your license. This may seem like an obvious situation, but with all the fluctuations in the industry, plus the latest hurdle we face, which is COVID, this definitely needs to happen early on in the phase, because if you don't have a license, you're not going to succeed. Next is to identify limitations. We could spend an entire webinar talking about our limitations, but think about your power, your budget, timelines, building permits, things like facility limitations, and also think about the limitations that your technology has within itself as well. Next important step is to establish your SOPs. Your SOPs are your procedures at which your employees are going to follow that make your business successful or not, right? Your procedures are very important to follow and yet understand how they work along with your business goals. Next important step is to hire people, right? You will need to make this decision between hiring people up front or bringing on a consultant with relevant experiences that can help you make these decisions for you. But don't forget about your project manager to keep things on track. This is very important. It's a hard job to face. Then is to educate yourself and your team on key terms for the technology that you're using. And this is the area we are going to focus on today. Next important step is to select your manufacturers. And by the end of the session, you're going to have a better idea of the way to choose the right vendor to meet your business goals, learning these terms and learning the metrics behind them. Last and final step, execute the plan. Work the plan and know that the decisions that you are making above directly relate to your profits and business model. So moving on, why are we here? You've all tuned in because you're planning a new facility. Some operators focus on yield, while others may focus on quality. But when we talk scaling up to a larger facility side, we have to bring in efficiency, because efficiency helps us understand where our bottom line is. And the bottom line, the more you scale, becomes more important. And this is how, think about how this impacts your business overall. So you always want to frame your new planning in a financial performance analysis. And at the end of this presentation, we are going to run through two different scenarios. One scenario with HPS and the other one with LED. And we're going to see how these different decisions impact your HVACD, your CapEx, as well as your OpEx when planning. So today I have the absolute pleasure to introduce two industry experts that are also good friends of mine who will be presenting today. First is Aaron. Aaron joins us from Fluence, and Aaron is the Director of Strategic Accounts for Cannabis and Lighting Design. He's also the manager for Fluence in North Americas. He's spent more than 15 years of experience collaborating with growers to optimize their growth facilities, as well as adopting new technologies and implementing innovative cultivation methods across multiple crop types. We also have Robbie Batts. Rob joins us from the Inspire Transpiration Solutions team. Rob is a passionate engineer with over a decade of experience designing, selling, and commissioning HVACD and process systems throughout North America. Recognizing a knowledge gap around fully understanding plant transpiration rates and how they impact controlled environments, Rob co-founded Inspire to focus on advanced transpiration solutions. Inspire's purpose-built systems for horticulture allow for precise environmental controls throughout the growing cycle and into the drying and cure process in manufacturing. So I'd like to turn it over to Aaron Fellabaum to discuss a little bit more about these lighting key terms and metrics. So take it away, Aaron.
Thanks, Casey. Hello, everybody. Pleasure to be here and to be talking to everyone who joined today. I'm Director of Strategic Accounts, as Casey mentioned. I've been with Fluence for 4.5 years, give or take a couple months, and am now just just trying to strategize as we move through this market as it's shifting and changing. And it's just been a pleasure to work with a lot of the people that I've gotten the chance to work with over the years. So to start, we can go to the next slide and talk about some key metrics that a lot of people are becoming more and more familiar with as the market shapes and matures, and as commercial ag starts to kind of coincide with what we're doing here in commercial cannabis. So I would like to just take a moment and kind of describe my method of helping you guys out today. And it's essentially to say, there's a lot going on within the lighting aspect of making an informed purchase when building a new facility or phasing out with LED or HPS. The best thing that I have found to do in just about every scenario to help people is to tell them to pull back all of the potential losses or reflectivities and just break it down to the science of PPF, which is our total flux output for each light. It is a financial driver, so to speak, an analytical tool that'll allow you to measure any lighting manufacturer against another in terms of what you're actually getting photosynthetically. So I like to kind of talk about it as a key photosynthetic driver for production within a cannabis facility. And it's the main investment you are making along with efficacy or micromoles per joule when making a financial decision regarding lighting. And lighting can get very cheap. Lighting can get very expensive. So breaking it down to the total output of one individual light or room of lights becomes a really powerful tool to analyze what you're investing into business-wise. We can assume that there's some relationship between light and yield of cannabis, and that it's relatively high in regards to PPFD. I can't say for certain if we even have a saturation point for all genetic varieties that are currently being cultivated in the medicinal and recreational market. So that all being said, on the right, I have demonstrated just a couple of the complexities, but breaking it down as easily as I can here. 121 single-ended HPS at 1,200 micromoles per second, equaling 145,200 micromoles per second per room. It's total room output of that flux. And the conversion rate from PPF to PPFD is 0.93. So we've seen about a 7% loss roughly, and that's brought me down to that 733 micromoles per meter squared per second on the bottom. In comparison, the same number of fixtures, the Viper 2P at 1,700 micromoles per second per, equaling roughly 200,700 micromoles per second per room with a 0.89 CU. CU is a factor of loss that all lighting systems and manufacturers incur. There's really no such thing as a 1 CU. There's always loss due to wall, due to egress, aisles. You know, anywhere a photon hits not a plant, that is a CU loss. And so that's an important metric to note. But that complexity alone, coupled with reflectivity and a few other factors, make it very hard to make informed purchases at the level of PPFD or light delivered. So we break it back down with PPF typically as a company, and we definitely implore that you simplify it and cut back on some of the noise associated with making that purchase. And I would recommend people do this not only for cannabis, but commercial lighting. I mean, heck, if I light up an office, I'm going to be pretty cognizant of how much my individual photon costs regardless of loss. Outside of that, a lot of the stuff on the left-hand side, these bullets most people know at this point. I just wanted to point out lighting power density because as regulatory bodies start to clamp down on what you do and in regards to lighting, it becomes important to understand what you're getting in terms of watts per square foot, or using, I guess I should say, for the micromoles per meter squared per second that you're receiving. This is something we're all kind of going through as an industry, and obviously, you know, the conservance of energy is incredibly important. It will ultimately see cannabis more than likely go towards more and more of a low-cost model where greenhouses are more applicable for the businesses that are popping up, and indoor cultivation, it'll be integral to run as most efficiently as you possibly can while trying to produce the best product out there. So it's an investment into your business, and it's all about optimizing the financial performance over time and considering that on the forefront if you can, so that you don't have to do it later. We can change to the next slide. Applied financial aspects to the investment that you've made. On the right, it's an embedded screenshot of the economic analysis of greenhouse lighting by Dr. Bruce Bugbee in Utah. And in the center there, it's kind of small, but you can see BML, or Build My LED, which was Fluence's first iteration at a 1.6 micromoles per joule. What that means is that at 2013-14, it was just as viable to use HPS as LED at a 1.7 micromole per joule that essentially was the same as double-ended HPS. Until that year, and the surpassing of that micromole per joule or efficacy, you know, the red and blue LED, it was a black eye in the at the time, and it's probably still stinging a little bit today. So now we're much better at 2.7 plus for broad spectrum LED. I just wanted to kind of point out that anything that you can read by Dr. Bruce Bugbee, you should. And, you know, now that he's doing research on hemp and cannabis, it's likely to lead to a lot more understanding of our plant. As it relates to your business and your business model, these metrics on the left are going to be the first steps to learning how to do a little spreadsheet farming. So, you know, it's going to be critical to start measuring some of this stuff, putting it into financial models, and then assuming that with more light, to some degree, you're going to get more yield. And whatever ratio you want to stamp on that, that's going to be your own preference. But it's certainly true, and it's something to look at. We can move on. I think a lot of this stuff most people business-wise are looking at, but if anyone has any questions for me after this, feel free, and I can give you a wealth of information on the subject. All right, so spectral quality. This is a little more abstract, but this is probably what I would consider to be the last piece of it, or at least the last piece of it to maybe look at. I think that everything in conjunction, you know, analyzing all these confounding factors together is definitely important and needed. Spectral quality is something that you also invest in. And there is a efficacy tied back to spectral quality. And so whatever your goals are, you are tied back to this micromole per joule. This is the piece that drives the economic value between HVAC and lighting, whether it's HID or LED. Every environment is different. Every need is different. If you're in a greenhouse, you certainly have the ability to choose a high micromole per joule and you know, take a hit on spectral quality because you're supplementing against the sun. So you might want the most bang for your buck in terms of you know, watts to photons in that space. To what degree, it's all dependent on plant, your cultivar, you know, whether it's tomatoes or cannabis, what the end goal is. And maybe you're just growing for biomass, and it doesn't really matter if the morphology of the plant is important, but maybe it does. And maybe if that's the case, then you're going to start to look at investing into broad spectrum, whether it's HID, ceramic, plasma, LED, whatever. The economics for that within sole source lighting become more compelling towards LED all day and twice on Sunday because of the HVAC implications and space utilization if you go vertical. So I'd say, you know, greenhouse on the left between LED, HPS, you know, broad spectrum LED, if you can make it fit financially, is probably the right choice. Then indoor cultivation, sole source lighting, always broad. As broad as you can, you know, tends to do extremely well in regards to secondary metabolite production, cannabinoid content, terpenes, etc. So again, you know, tying your spectrum back to efficacy and the long-term goals of the facility, incredibly important. You can switch slides. Ending here is something that we've been trying to express as a company for the last 5 years or more, and that's that lighting fixtures don't grow crops. Individual fixtures and the cost associated don't matter. What matters is the photons. What you're purchasing is a total amount, and regardless of all the noise surrounding the trend, the conversion, I guess, from PPF to PPFD, spectral quality, because it's all pretty detailed and nuanced, by the photon, not the fixture. Focus on maximizing yield per cubic foot by choosing high light intensity, driving photosynthesis with that investment into PPF, and then in turn PPFD. Minimizing the operating cost per pound as a secondary piece to this. And I'd say this is order of importance, you know, first to last here. You know, OpEx is important, but don't focus solely on OpEx because you'll never save your way to prosperity. And if you do, it's definitely trumped by any yield increases that you could incur while getting there. Augmenting pricing power through qualitative and consistency metrics. It's just, with LED, it's more of a long-term play. You're going to be in that unit for many years to come, and investing into that spectral quality and lack of maintenance over the years is incredibly impactful if you're doing any type of TCO analysis, you know, long term. And that's it for my part. With that, I think I give it over to Rob.
Yeah, Aaron, thank you so much. It's always enlightening to have the Fluence experts themselves deliver lighting wisdom. So please consider it my pleasure to have the stage with you guys today. For everyone watching at home or in the office, take note that every single slide about HVACD that I present to you is tied to lighting in one way or the other. So we're going to go through the slides, and you're going to maybe make notice of that as we go through them. I'm going to talk about the key parameters of plant vitality today, and specifically the ones that HVACD directly controls. I'll break them down from easiest to manage to hardest to manage and give a little explanation why. And yes, don't worry, I'll be talking about VPD. We'll absolutely get through that. Then I'm going to talk about the impact these parameters have on your business bottom line, how a failure to maintain any one of those parameters will have a detrimental effect on your business. And we'll show you some metrics we see emerging in the industry, which have become the leading indicators that successful entrepreneurs focus on, and they're using them to maintain their competitive edge. And lastly, on the second last slide, I'm going to share with you real data that should probably be the cornerstone of any successful HVACD design. Next slide, please. So at Inspire, we identify 10 cardinal parameters for plant vitality. And this also borrows heavily from the work of Dr. Bugbee. The 4 parameters that land in the Inspire wheelhouse are humidity, temperature, CO2, and airflow. In terms of managing the parameters, the easiest to control would probably be the CO2 and the room temperature. CO2 because I really only have 2 options. Either I'm going to supplement CO2 into a room, or I don't. And these devices have been around for a while. They can be bought as standalone components or integrated into your HVACD. And there really isn't much improvement here to opening and closing a solenoid over the years. So that's a pretty easy one to control. Room temperature is another easy one. Frankly, most HVAC systems are geared to control the temperature of a space with humidity as an afterthought. And when people get environmental control wrong, the typical engineering error is to get the humidity control wrong, but the temperature control pretty close. Speaking with lighting providers like Fluence, I hear it all the time. An engineer or contractor says, hey, send me the total watts of your lights so I can size the HVAC system. I mean, this drives me nuts. This is the wrong approach. This approach lacks the depth of understanding of the dynamics of a high-density, high-transpiration environment. And we're still struggling against the shackles of the temperature control approach today. It's really, really frustrating. So the next parameter, airflow. Airflow is one of those intermediate difficulty variables to control. There have been real leaps and bounds in this area with fixed and floating intercanopy airflow delivery systems, and this is critical to consistent canopy conditions and microclimate elimination. We always talk about putting intercanopy airflow systems into every room that we're involved in. It's just a great recommendation, and I would recommend it for anyone designing a new facility. Now, from our perspective, however you decide to move the air around the room, we are going to perform a CFD model for that space, a computational fluid dynamics model for that space, because it's so much more cost effective to go into a project with a 95% certainty that you've got the airflow going where you want it to, as opposed to making a mistake and then having to redo everything afterwards. Anyone who's been responsible for delaying plants on racks for a week or 2 knows the wrath of an angry grower. It isn't worth almost any price. So what are the last 2 tough ones to control? Well, that's humidity in a room, and that's also leaf temperature. Let's start with humidity. To stress how important humidity is, we are forcing people to reconcile this fact by only using the term HVACD as it applies to the Inspire controlled environment horticulture products. What is the D? The D is for dehumidification. It is incredibly important. Never forget that the focus of your environmental control systems is removing water from the air inside the room. Next slide, please. So let's talk about leaf temperature. This is the last of the parameters that HVACD directly controls. This is important, so you really want to get this right. The industry at large has not defined a really good way to figure out leaf temperature yet, but it has a direct impact on leaf metabolism. We see on this graph here, as we get into a sweet spot of leaf temperature, we have a high point in carbon assimilation through photosynthesis. I won't get into all the different challenges of determining the right leaf temperature to take from your measurements inside your room. It's probably a 40+ minute discussion in and of itself. But of all the measurements you take from your room, you definitely should have a consistent, if not accurate, way to measure leaf temperature. Next slide, please. So how do all these variables play together? The interplay of leaf temperature, room temperature, and humidity, that is the core of VPD. And while the definition of VPD is pretty straightforward, the dynamics and consequences of getting VPD wrong require a bit more study, because it really requires an understanding of a very nonlinear multivariable equation. So if you've been on any growing forum in the last few years, you just can't ignore how pervasive VPD is as an idea driving cannabis vitality. The industry has become enamored with VPD discussions, and with good reason. VPD is the driving force behind transpiration. You control water movement through a plant by controlling the VPD. Now let me restate that. You control the flow of water through a plant by creating a depression of moisture in the environment outside the plant. And you also tangentially control so much of the physiological functions of the plant with VPD. And mobile nutrient uptake, photosynthetic rates, CO2 assimilation. There's other functions I haven't mentioned, but at the end of the day, this alone should be enough to make you want to understand VPD better. Next slide, please. And here it is in very simple, easy to understand instructions. Here on this slide, we see a very clear roadmap to the concept of calculating VPD. Just follow the steps. Find your leaf canopy temperature, find the surrounding room temperature and humidity, and then derive the VPD from your psychrometric tables. And yes, this is very straightforward, but it's also basically impossible. And that's why we built an Inspire Cloud suite of applications to modulate temperatures and humidities and maintain a constant VPD. So there's a reason for this. You'll notice that this slide doesn't say, go to the VPD chart on the wall that you've printed out and look up the VPD from the chart. The reason you need a control system to handle VPD control is because VPD is a dynamic number. If you've printed out a VPD chart, you printed it out at a very specific point in time. The time when the leaf temperature is whatever it is when you generated that chart. Now, this is as egregious as the mistake of designing HVAC systems for a temperature, for a grow room using a temperature control perspective. From day to day and even from hour to hour, your leaf temperature will change. And prove this to yourself. Go and play with any good online calculator for VPD. And you'll be forced to notice that changes to the leaf temperature force a complete redrawing of the VPD chart. Next slide, please. So let me tie this back to a concept I mentioned on the first slide. I need to hammer this home because it's very, very important. HVACD decisions can only be made once a lighting technology decision has been made. We're about to look at two very typical, but also very different VPD charts. On this page, we're looking at a VPD chart indicative of conditions in a flower room lit by LED lights. Now, an LED light does not heat the leaf nearly as much as other lighting source types. So the leaf temperature, if we were to do nothing with the room conditions, the leaf temperature would actually be cooler than the room because transpiration out of the stomata from the leaf has the effect of cooling the leaf below the surrounding room air temperature. So if I want to maintain the leaf temperature in that sweet spot on that leaf temp curve and carbon assimilation curve, I need to counteract the cooling effect of transpiration by keeping the room air warmer. On the slide, we see that we maintain a 1.5 kPa VPD when the room humidity is at 50% and the room temperature is at 82 Fahrenheit. Next slide, please. Let's apply an identical growing strategy to an HPS lit room. And this is going to require a very different room temperature. See, in the HPS room, I need the room maintained at 75 degrees Fahrenheit as opposed to 82 to supplement the cooling effect of transpiration on the leaf. And only then can I maintain my leaf temperature in that sweet spot on the temperature carbon assimilation curve. Now, this isn't arbitrary data. I've picked 1.5 kPa VPD because that's the number that allows for a high enough transpiration rate to support plant metabolism in mid to late flower. And I picked 50% relative humidity because this is a humidity threshold where pathogen expression is close to minimum. That's a good thing. And these are the same room. These are the same plants. My VPD is at 1.5 kPa. The relative humidity is 50%. But if I made the decision to use LED lights instead of HPS, I have a room that's 7 degrees Fahrenheit warmer than the HPS lit room. Now, we're going to get into this on the later slide deck and later slides in the deck. You're going to see exactly what impact this has on your HVACD purchase and really on your bottom line. Okay, so we have laid the groundwork to discuss all these parameters' impacts on your business's bottom line. Next slide, please. So here are the KPIs and metrics that we've seen surface as evaluation tools for cannabis growing facilities. What you might find most interesting, if you take a long enough time to look at this slide, is that there's very little attention paid to operating efficiency. This is by design. Only one of the business profitability metrics has to do with operating cost. And the pound per hour per kW metric, I mean, that's really only something that we at Inspire bring up when we're talking to utilities. The fact is that the fiscal returns on growing potent and desirable weed will outstrip the efficiency savings of your dehumidification system for as long as you're growing in that facility. There's nothing wrong with efficient growing. Don't get me wrong. You absolutely should be doing that. But I want to share with you a real world example. We were involved in a project where there was a 2,000 square foot canopy that was outfitted with brand new premium efficiency Inspire systems. And I'll point out here that the Inspire systems are some of the most efficient on the market. Now, the grower cut their operational costs for rooms that size by $9,300 year over year. Hey, that's pretty good, right? But in that same room, the consistency and flexibility that the Inspire HVACD system brought to the environmental conditions got the grower from 35 grams per square foot to 45 grams per square foot. He made over $580,000 more in that room in that year than he did the year before. So if a 62-to-1 ratio of revenue generation to operational savings isn't eye-opening, then I'm just going to keep repeating it until everyone gets on board. But maybe I could say it another way. Inspire HVACD systems are not here to save you money. Inspire systems are here to make you money. So when you might be asking yourself, when Inspire designed their HVACD systems, why do they design it so efficient if efficiency is such a not important metric? Well, we didn't do it because it increased operating kW savings. We did it because those very same efficiency features are used to deliver the most flexible and powerful dehumidification and temperature control mechanisms on the market. I'll give you an example. We reduced compressor size, and this allowed us to minimize time-consuming and expensive electrical infrastructure upgrades. We included a cloud monitoring app so that growers could make real-time decisions about the state of their rooms. And further to that, every one of our units has got a room controller built into it. It's just one less thing you have to buy, and it's already integrated into the brains behind the environmental control system. And as part of that, we developed a VPD control algorithm because we know that that's how you make plants thrive. We modulate every single component inside our devices so that we can deliver consistent temperature and relative humidity to happy and thriving plants. Okay, so how do you turn your flower room into a star performer? It takes a lot more spinning plates than I just mentioned. You've got to get CO2-rich air down to every leaf in the canopy in a very consistent way. You also need to eliminate microclimates, the kind we see when we see conventional non-integrated systems installed. And you need to keep your temperature and humidity swings to a minimum. If you can do all this, then you're really doing your part to minimize the breakdown of what's called the pathogen-host-environment relationship. If that pathway breaks down, you get disease emergence in your room. Once that pathway breaks down, you've exposed your entire facility to higher IPM cost, increased risk, and reduced competitive advantage. Next slide, please. So we just covered a lot of very complicated topics, but I want to start with the basics. Again, we see the basics being mishandled all the time, and I want to to hammer this home so that everyone can walk away and understand why we use the numbers we use. Let's talk about what is the baseline on how much dehumidification horsepower and capacity you need. We lean on this slide a lot because it so accurately depicts the dehumidification requirements in a flower room. So studying this slide, on the right-hand side, you can see that we've gone through the expense of measuring the amount of water transpired in entire canopies between daytime and nighttime in a single room. This is for a typical LED lit grow. And we've normalized the ratio of daytime to nighttime against the daily total of water consumed by the room. So if we're going to follow the formula on the left, for a flower room, you could use anywhere from 75 to 80% as the percentage of moisture removal during the day. And this will be a great starting point and almost a fail-safe way to ensure you've got the right amount of dehumidification capacity for that space. Next slide, please. Okay, so as I finish my portion of the discussion, here's another formula for you. You can combine the genotype of the plant with the environment around the plant, and you'll produce an internal physiochemical reaction that will result in a specific phenotypical expression. If you understand that formula, then you know that you have to master your environment to make the most of your genetics. Conversely, we shudder at the recollection of all those conversations with all those entrepreneurs who failed to control their environment and therefore failed to meet their business goals because of it. We know because when we see an HVACD system underperforming at a facility, we feel that we were not effective enough at communicating the messages that we've relayed today. And I hope that you guys can take that to heart and make sure that you use the lessons we learned in your own facilities. Aaron, back to you, buddy.
Wow, that was awesome. I want to...
Casey, sorry.
Yeah, no worries. Thank you, Rob. I want to thank both of you for helping us connect the dots, essentially between the lighting world and the HVACD world, which is obviously, as we've heard today, very synergistic and very important key metrics to understand when designing not only your business model, but then your facility afterwards. So I appreciate you guys. So now to the next session. Here we're going to provide you with one more checklist, which you're currently looking at. This one is a bit more relevant to choosing your manufacturers. But then we'll run through these key metrics to compare a 10,000 square foot facility and look at the differences in CapEx and OpEx between both HPS systems as well as LED systems. So getting to the checklist. First, I would like to say there are many different decisions that you have to make when figuring out what to implement in your new build, like irrigation, fertigation, sensors, other equipment, so on and so forth, right? But this checklist is going to focus primarily on HVACD and lighting considerations, as well as the synergies between the two equipment. So like Rob mentioned, choosing your genetics is a very important step. And not only choosing your genetics, but understanding what your genetics are bred to achieve and how to achieve that based on your environment. Because the type of genetics you are deciding to grow really determine the way that you are going to handle your environmental settings and set points, right? So choosing genetics is a very important step based on your goals, should not be overlooked. Then know your facility. Understanding your facility design. Where's your cultivation space versus where is your curing space? What rules apply to each? How much space you need? Whether you have requirements in your local state laws. Knowing this and understanding what you need to achieve when designing your facility is very important. And this impacts your HVACD decisions. Thinking about your curing space and the wet weight or the timing and design of temperature and relative humidity curve. Consistent moisture content of the finished product for consistency, quality, and quantity. Also, ensuring HVACD equipment is sized to account for watering rates and evaporative transpiration based on photo period. And like Rob has said, a lot of HVAC companies get this wrong because they're focusing on temperature adjustments as opposed to focusing as well on moisture removal, which is a big key fact in cannabis and other crop cultivation. Next thing, as And talk to your lighting provider about your lighting needs for each room. And this is especially important when considering photo acclimation into your cultivation strategy. So what are you trying to achieve? What are your genetic potentials? And what do you want to see as far as your CapEx and OpEx as it relates to gained revenue? So then, knowing your lighting type, whether you're going to go with a HID system or an LED system, and understanding the capabilities, but also the limitations of both of those types of equipment. And this will help you size right your HVACD equipment to minimize your impact on your facility's limitations, right? Which means make the most out of your opportunity, right? Money spent on HVACD, there's biggest canopy limitations due to the number of plants. So it's very important to size your equipment accordingly to what you're trying to achieve. Then understand manufacturing lead times with your installation time. This is a very important step that a lot of people don't really see as a forethought, right? They get into a situation where all of a sudden they call us and say, oh my gosh, we need lights tomorrow. And obviously, you know, that's a challenging situation for lighting, and even more challenging situation for HVACD. And so understanding your timelines of when you want your plants in the ground and working back from there to understand what your manufacturer's lead times are extremely important to the process of your build. And then we begin to incorporate lighting and HVACD into our program and execute. This process is going to set you up for financial and facility design efficiency and success. So now with that, Aaron mentioned a little bit earlier about spreadsheet farming, right? You know, some people have a hard time not understanding the economics of what they're trying to achieve and what they are achieving. Some people understand a little too much with spreadsheets only as opposed to practical application. So what I did in this financial performance analysis is I put two different scenarios together to show you the difference in CapEx spent, right? And so the first scenario is a double-ended HPS room, which we used a 400 fixture quantity for, right? 10,000 square foot blooming canopy, right? So what we did is we added the exact same number of fixtures for the Viper, right? Which is our high bay LED option that we replaced a double-ended HPS with, right? So you can see moving down a little bit, the price per fixture is quite a bit different. And we went with 200 for the double-ended HPS because it's an even lower amount than most people could even fathom getting an HPS fixture for, right? But just to prove the point about how we have to look at the overall scope of the project to determine, you know, which way to move forward as far as our budget is very important. If we get hung up on looking at price of fixture, then we're going to miss the rest of the opportunity, right, that we have to achieve success through efficiency, right? So as you can see, a $200 fixture for HPS is quite a bit lower than a $1,000 Viper, right? We also have installation costs. And so given those two costs, you have quite a bit more of a budget that you need to account for if you're planning on an LED facility, right? Now, this is just looking at the spreadsheet. When we talk about the system holistically, which is what Rob and Aaron have both been conveying in this webinar and the presentation, we have to look at what one choice affects the rest of the choices and the rest of the decision, right? And the lighting choice is a very important choice that really affects how you move forward with the rest of your system and designing your cultivation facility, right? So now when we compare the amount of energy, the amount of cooling, and the amount of moisture removal that needs to happen when you're comparing an HPS room of the same fixture quantity to an LED room of the same fixture quantity, we start to see that this fixture price is actually looking pretty close to the same thing. And actually in this scenario, we're gaining a delta of $81,000 with our LED room. And this is obviously because of this capacity issue that we're talking about. Yeah, as the HPS light itself, the double-ended HPS light, you might get a making deal on $200 for fixture, right? But then you have to overcompensate for that when designing your HVACD system, right? To overcompensate that irradiance, that heat load, and what the difference is as far as your plants and how they transpire that water. And so as you can see, if we boil it down to the overall system, the double-ended HPS room doesn't sound too appealing when you're looking at an $81,000 delta compared to the LED room. So now this is just the CapEx, right? And this is at the optimal temperatures that Rob was speaking on earlier, right? The optimum temperatures for HPS and the optimum temperatures for LED for consistent, successful production, right? So this is just the CapEx. This is the money that we have to come up with and put up front. So this is sounding pretty good for moving with the LED option. And I do want to also add, this does not even include any incentives, utility rebates or incentives. There's a lot of incentive programs around the country that offer you money off of your LED fixtures to make that more efficient choice, right? So you're already in this scenario gaining $81,000 off of what you would have spent to design the HPS system, then add in whatever rebates incentives that the local utility programs give you, even bigger delta of savings. So now this is the CapEx, right? Let's talk about our operating expense, right? The operating expenses, which is what you are going to continue to pay every year of operation, right? And as you see, there's a big difference between what it takes to operate the HPS room, the double-ended HPS room, compared to the double-ended LED room. And in this case scenario, every year you're gaining a delta of $217,000 going with the LED system compared to what it takes to fully create a stable environment for a double-ended HPS system, right? So if we're comparing just fixture to fixture cost, yeah, we might see a very skewed result with the LEDs being much more expensive. But when you relate this to the overall build and what you're trying to achieve as far as the synergistic relationship to how your equipment interacts with each other, we're seeing a gigantic number of savings every year on your operating expense while choosing this efficient system, right? Which is what we're talking about, the efficient system. So not only is it you're gaining delta, you're gaining revenue, or you're gaining a delta of what you would be spending on one system compared to the other, you're also gaining quality, you're also gaining consistency, you're also gaining yield, which also increases to revenue increase. And so without even discussing revenue increase based on performance of the actual crop and plant, you are gaining money by choosing one system compared to another system. And this is a very important thing to take into consideration because it's not just one system that you are paying for in a CapEx or OpEx. It's how everything affects itself. So before we open up our session to questions and answers, let's review some of our key takeaways. And don't forget about the rebates and incentives, as I mentioned, for both lighting and HVAC sides. This is something that you want to work on with your local power provider as you're working on it with your HVAC team and your lighting team. So this is something that works with simultaneously throughout the whole process. That way you ensure that you get your rebates and incentives at an appropriate time frame. And we can help you out with that as Fluence. We file rebates for people, as well as asking the HVAC team Inspire can help you with that too. So if you feel lost on not knowing and understanding how to achieve those rebates, just ask one of us and we can help point you in the right direction. If not, help do it for you. And think ahead and start planning for the pricing pressure. Like I said, I come from Oregon, and a few years back, we hit this bubble to where there was way too much product and people were selling indoor product for $300, $400 just to get it out the door, right? So now that isn't the norm moving forward, I hope, right? But we have to understand that there is going to be price compression, right? And watching out for that bottom line is extremely important to begin with, right? Because that's the survival, focusing on the efficiency, focusing on getting a gigantic output for the littlest input that you possibly can. And that's with the efficiency. So, yeah. So let's see. We're going to just touch base with the panelists really quick and see if they can provide any kind of key takeaways from the presentations that they gave before we get into our questions and answer time. So, Rob, can you provide a couple takeaways from the presentation that you would like people to remember and take with them from this opportunity?
Yeah, absolutely. So yeah, Casey, thanks so much for kind of summing it up and putting it into that spreadsheet. It's nice to see it all condensed into one spot. You know, the takeaways are actually less technical than I think the content of my portion of the presentation is. The takeaway is use real data whenever available, right? There's real value in the rules of thumb that legacy growers have developed. And I never look down on that kind of information. It's real data, even if it's only anecdotal. The problem is that rules of thumb are sparse from a data perspective, and they don't capture the outliers or nuances. And so, use as much real data as you can as opposed to the rules of thumb. I'd also say avoid speculation. If you're making a decision, go as far down the hierarchy of knowledge as you can. Find out why you're making one decision over the other. You're putting your entrepreneurial spirit to the test here. So many decisions impact so many others. So the best thing you can do is probably mind map all your choices and keep track of all the ideas in one concrete way. And seeing all these decisions in one spot will really help you understand that this whole endeavor is a delicate balance between risk and reward. And that's the only thing I would say about the takeaway here.
Wonderful.
Aaron,
Thank you, Rob,
you?
on that. Aaron, how about you? Give us some key takeaways from what you've helped us understand so far.
Sorry, I started my video on accident. Thanks, Rob. Thanks, everyone. My takeaways, I suppose I would say just, minimizing, try as much as you can with the help of anyone that will provide you with the information that's needed to do so. But get the data, get obviously the data that you're purchasing upon. So what are you investing into? And I think that ultimately it's photosynthetic capacity or capability within a given space or market. So take whatever limitations are there for you, whether it's regulatory or, electrical or space, space is constrained. And then consider those limitations or challenges when you're making the decision to purchase any type of lighting, whether it's LED or, induction. So invest in photosynthetic drivers and focus on revenue in order to optimize the financial performance of your system as a whole, and look at the long run, because cannabis is a money machine right now in some ways, maybe for some people, maybe not, but it's not like commercial agriculture. We still have a lot to use, to invest into, and to produce, given the cost per pound, even as it's starting to decline. So just consider that, whether you're building a business to sell it or keep it forever, or, start to build other businesses in other states, just make sure that the long run is your focus and invest into that.
Absolutely. Yeah, it's we see it more often than not that there's about a focus of a week to a month in front of their face, and the rest it's who knows what to expect. So seeing that roadmap and trying to plan for that roadmap is absolutely an important concept. So thank you both for those key takeaways. It's fantastic. Now I would like to invite our panelists to turn on their cameras while we begin answering some incoming questions from the Q&A section. I'm gonna wait for everyone.
Do you mind if I just introduce Jesse Porter?
Absolutely.
From our team here? Jesse's going to be joining us for the Q&A session. Jesse has been a cornerstone in rethinking the Inspire business model in terms of being more plant focused and plant forward. He's got over 15 years of hands in the dirt, growing cannabis. He's got a number of cannabis cups to his name. I just like to introduce him to everyone watching today, because he's really been a very, very strong resource for us over at Inspire.
Thanks for having me, guys.
Yeah, thanks for joining, Jesse. This is awesome. Got a lot of good knowledge on this panel today. So bring some good questions and send you some solid answers. Let me just get my video turned on. Perfect. So let's kick it off with a question that we have from Doug. And Doug asks, if VPD for LED is optimal at 82 degrees, for 75 degrees for HID, is there additional overall energy savings by less cooling load, or more about the same? Rob, can you comment on this here?
Yeah, so the load actually doesn't change. Most likely the transpiration rate in the HPS room and the transpiration rate in the LED room, because we've got the same VPD, of 1.5 kPa, the transpiration rates are going to be equal. So your dehumidification load doesn't go down. What goes down is the amount of energy required to take the humidity out of the room. So a room that's warmer at the same relative humidity will need less HVACD and dehumidification in compressor tons than you would otherwise in a cooler room. So that's the reason that there's energy savings from one room to the other. Does that answer the question?
I just want to sort of jump on top of that too. It's like the way I usually say it is you're going to get more capacity and capability in that LED room because the temperatures are held hotter. And it's just like Rob said, you're just going to be able to do more with the same unit in an LED room versus an HID room.
Yep. And it's important to remember something that Rob said earlier. Most HVAC companies are designed for human spaces and conditions and environments, right? So they focus on the temperature and manipulating the temperature in the room. But in our scenario, in our case, we're putting something in the room that's a living, breathing thing that's continually pulling in and releasing moisture. And so that now we're able to understand that we're focusing our HVACD for a completely different purpose than what it was originally designed for. And so focusing on cooling your space is almost a secondary thought now for what we need to be doing. And so appreciate the answers on that, guys. So we have a question from Joseph. How is Fluence reacting to LED incentive programs being cut out by the state of California? As well as local utilities. The state views incentives for LEDs as anti-competitive. Can we expect LED fixture costs to come down anytime soon? Aaron, could you answer this one for us?
Yeah, great question. So there has been some changes or proposed changes, I think, to my knowledge, in the state of California that would potentially force everyone to start to look at more energy efficient lighting. That might be what we're talking about here. But yeah, I think that we've seen some differences in the way that incentive programs work around the country, such as Massachusetts, as an example, in Illinois. Just before I go any deeper, we are going to have a webinar on this subject. It is incredibly important, but it is an intricate topic, so to speak. So incentive programs will generally change and move around based on the regulatory bodies and the people that are funding these utility companies for our energy. They're always in change. They change every year. Every year, your utility goes back and they write new grants for themselves to say, I gave this much energy out this year, and then you have a budget. And so it's an ever-changing answer to that question. So continuing to stay in touch with Fluence or anybody that you can that has been tapped into that, I think that's a great idea. Resource Innovation Institute, who we partner with on this webinar, also a great resource. They push for this stuff in the utility space. They say we need to get people using more energy efficient lighting and promoting that. And that's the same for HVAC. And so the focus for RII is great. You can reach either Fluence or RII after this to learn more. LED fixture costs, I'll try to be brief. In 2015, when I started at Build My LED, we sold I think a 1500 micromole per second system for $3,000. So use that as a starting point, and then you could take any MSRP on the market today and look at the decline in dollar per photon over time. It's there. I mean, it's a product, at least for LED, of the commercialization of LED lighting as a whole throughout every market. It's going everywhere, right? Your street lamps, your warehouse lamps, everything is now LED, and so it's becoming cheaper and cheaper to produce and then build and distribute for horticulture purposes. So the trend line is there. It's pretty easy to follow if you look at some of the historical pricing and then graph it out. I would say yes, in general, LED specifically, not everything else, is generally declining in price. And that's part of probably the next step or next evolution in LED technology in terms of its evolution. So it might not take it too much more efficient, but it will get cheaper.
Right. It was a great answer, Aaron. Thank you for that. Rob and Jesse, what kind of incentive programs, what are you seeing as far as the incentive programs for HVACD, and how do you help customers navigate those?
Yeah, so we bring to the table a wealth of data from previous facilities, and that's important because an incentive is different than a rebate. A rebate happens when I purchase the light, I say, hey, look, I bought all these lights, and look how much more efficient they are, and someone hands you a rebate check. Loosely. An incentive is different. An incentive is before the customer purchases the HVACD, they have to analyze alternatives and get an understanding from the utility that, hey, if we make this choice, we save this much money and we're consuming this many fewer kWhs, right? So it has to be driven by the consumer decision in concert with the utility. And this all happens, 6 months before the equipment's purchased. So lights, at or after the purchase of the lights, you can get a rebate. Incentives for HVAC start way beforehand. So what I'd say is our job is to help people understand that before you even get to the point where you've decided on a piece of equipment, you need to engage the utility. And we're happy to, help with that. We've seen it happen in a number of different jurisdictions, and I think we know the ins and outs of the conversation to make sure that you can get the incentive you need, or you deserve rather, from making the choice of one technology over the other.
Right. Yeah, and that's important. Understanding what is available to you in your area based on your power company is very important to understand that timeline and how you're going to achieve that incentive or rebate moving forward. So again, like we're saying, working with the Inspire team as well as the Fluence team as early as possible to navigate those incentives will help ensure that your timelines are met on that. So a cool topic, we've gotten some questions that have to do with CFD modeling, and it's a pretty interesting one, exactly. And so one of the questions is, does your modeling include the plants and the actual spacing in the room? How can you achieve 90% certainly with the variability of the density of the plants, which forever changes, size, density of the canopy itself,
Sure.
Those type of things.
Yeah. So 95% certainty is a number. It's a number that reflects more my gut feel, which is we're doing it basically right, as opposed to a number that comes off a spreadsheet because we are 95% certain it's going to be there. There's a lot of data out there, and if you want to just do a Google search for canopy airflow resistance, they would take canopies of plants, put them in wind tunnels, and determine the resistance of the airflow through them. Now, you don't put a plant in with all its leaf detail included. What you put in is a block of canopy, and a block of canopy at a certain stage of growth is going to act a certain way in terms of airflow resistance and which direction the air is moving, all that other stuff. It was a big project. It was no small feat to come up with the canopy model object that we put inside of our rooms. The answer is we think we got it pretty good. We can relay the CFD model details into actual rooms and say, hey, we're plus minus 5% here. So that's a little bit too close. Plus minus 10% is probably about right. But yeah, we do a pretty good job of it, and it can be done. It's an hour-long discussion, unfortunately, but whoever asked that question, send me an email. I'll point them towards the papers, and they're more than welcome to go and double-check my work.
Right.
And I want to say this too, real quick, is that so when I first joined Inspire, Rob was just screaming about CFD modeling, and I was like, "Cool, sounds great. Tell me about it. Walk me through it." I questioned every bit of science that comes across my plate, and the guys will tell you as much. So I was quick to say, all right, well, what about this stage of growth? What about this genetic? What if I defold now? What if I defold then? What if I do it? All these other components that I really wanted to make sure were a part of it. And, then Rob was quick to ask me, well, practically, how do you do your CFD modeling now? I said, well, I tie a string to a stick and walk around the room and see where the air flows. So I'm one step ahead of a lot of people, and then I'm actually trying to figure out where the dead spots are and where I need to put my fans and where I need to break up microclimates to mitigate risk. But Rob makes an excellent point, is that it's a tool and we have to understand how to use it as a tool. And I think Rob is excellent at that and has taught me a lot over the time that I've spent with him. So again, it's not perfect, but it's way better than a stick with a string on it or a windsock or whatever other sort of, legacy style approach that you've used to solve the problem in the past.
Yeah, you're moving that stick with a string after you've built the room, right? So,
Of course.
And I was like, oh boy, we need to move all these racks now because, what a pain in the butt, right? We're trying
No
to
plants
avoid
in that
those.
corner. Don't do
Yeah,
that.
right. Yeah.
No, that's absolutely true. A tool has the ability to use it in many different ways and many different perspectives, and using the tool is only as good as the information that you have to put into the tool, and there's no way to develop a good CFD model if you don't have the proper information to put into that tool in general. But then as well, after you build and develop that, in understanding the commissioning of that, there might need to be some manipulations and some changes. And so, 90 to 90% on a wide variety of options and scales. But then it's up to us to go in and look at those little micro adjustments that need to take place based on what our canopy size is, how we prune our plants, what our genetics look like. There's a wide variety of things that can change that airflow. And so having a good understanding of that modeling beforehand and then going in with the fact that we might need to manipulate a few things is definitely important. So on kind of that similar topic, Aaron, you mentioned earlier lighting designers in your opening sentence. We have a question from a viewer regarding these lighting plans and mounting heights. So how does a grower or a lighting designer know or understand the ideal mounting height of a fixture?
That's great. Great question. And it's one we've gotten as a company year after year, day after day. We probably answer this pretty regularly. I wouldn't even know how many times that answer has probably been produced by Fluence to somebody, but mounting height varies based on the way the light distributes, whether through a reflector or a secondary lens or optic system. So depending on whether you're talking about HID or LED, single-ended, double-ended, they all have different methodologies, so to speak, to spread that light out. For LED, it becomes a little easy, let's call it easier in most cases, because you have what's called a 120-degree beam angle, which means generally speaking, the distance on your x-axis, let's say, becomes a determining factor in optimization for uniformity's sake. So it's called spacing criteria. And with 120 degrees, you have a 1-to-1 criteria. I'm going to go ahead and put this on my screen here to demonstrate. But right here, we've got a set of lights. And that set of lights is 15 feet apart. So this would be obviously a greenhouse, right? And the lighting density would be relatively low for this greenhouse just because they're so far apart. So you probably have a low PPFD supplementation, maybe for lettuce, whatever. But at 15, does that say 15? I think it does. Whatever that says, that would be the distance to your crop to shoot for optimal uniformity. If you don't have that elevation to utilize, lowering your fixture will produce a worse uniformity. From that optimal point, raising it up, you'll just have a worse CU. So basically more loss to the wall. And this is kind of the guiding factor for 120 degrees. It changes with other light sources, reflector types. We actually sell a reflector, not an optic, that can spread light into a 2-to-1 ratio for greenhouse producers or people who have low elevation ceilings or whatnot. I think it's helpful to think of it also like a spider, right? So if you look at a spider light, which is one of our close proximity systems, it has about an 8-inch gap between each light bar, meaning there's no optic there. It's 120 degrees. So 8 inches, 6 inches, that's optimal. And that's going to get you the maximum uniformity without hindering your CU or coefficient of utilization. And I'll just do one more here and just show a Viper install indoors. That's probably 4 feet, something like that. And 4 feet to your crop, you have optimal uniformity. Now, whether you choose to keep your light at that point and let your plants grow into it, or raise and lower your light, that's a decision that you got to make from a financial decision. And commercial facility, you don't want to raise and lower your lights. You want the plants to grow into the light intensity. A hobbyist might want to save a few bucks on their energy costs, so maybe they'll lower it down in their closet or whatnot and save a couple bucks there.
Right. And so one thing that I understood from that too is with the LED technology, we have the ability to adapt a little bit more specifically, right? Whether you are looking for that more light intensity, whether you're looking for a better space utilization, it gives us the ability with a wide range of controls and installation requirements to be able to do that. Unlike HPS systems where you have a specific height above the plant, so you have to keep it at, or you have to dim down the wattage, which also takes out your spectral composition. So you're using a tool that is adaptable to many different circumstances.
That's true. And I would end that on the note that anytime you add some type of optic, there's always a loss associated with that optic in some way. So if I put an HID bulb into a reflector, there's dust accumulation over time. There's, there's diminishing photons because I'm hitting the reflector and using that to drive it to the canopy. So omnidirectional systems like LED become a little bit more attractive just from an optical loss perspective. So we have reflectors that are released. They were released last year. If you have a low elevation greenhouse or low elevation room, we can definitely talk and talk about what those optics, their costs and the losses due to your financial performance.
Awesome. This one is kind of a two-part question, and it's on the HVACD side of things. So the first part of this question is, Rob, you mentioned a little while back that there was a project that your HVACD systems were utilized in that actually increased yield by a considerable amount. What type of system was previously installed in that space?
It wasn't yield, it was an increase in revenue. So that's very important to understand. And the nuance of whatever expression you get in the plant can change the plant value drastically. So just keep that in mind. It's not like we drew that many, we grew that many more pounds. We probably did get more pounds out of the room, but that's not what I was talking about. Yield and revenue are two very different things in this context. So keep that in mind. The previous system before that, it wasn't just an HVAC, system for the room. That room previously, these were two different facilities, but of the same canopy size inside the room. The original design of those rooms didn't have in-rack airflow, systems, for example. It didn't have VPD control, for example. So I wanted to drive that point home on the metric slide. It's not about the HVACD you supply. It's about, did you give it enough capacity? And did you have all the other spinning plates worked out correctly? So, without throwing anyone under the bus, the fact is you need to have all those things moving and integrated as much as possible to get that kind of result. And they just didn't have that in the original designs.
I want to add in too, that's a facility that essentially went through a retrofit. So it was really fun for us to sort of go in and see the mistakes that were made. And we've seen a lot of those over the years, but also to fix those mistakes one step at a time. And the thing I want to stress is that, Rob did mention the yield increase that we got over fine tuning and refinement of all those spinning plates, but also the risk mitigation. I mean, they were not able to get to market with a significant amount of their product because of their inability to control microclimates. Like Rob mentioned, the in-rack airflow, with powdery mildew, with botrytis, with failed test results, there was product loss associated with product that need to be destroyed for health and safety. And as a result, I'm not going to claim a yield gain just because you had to destroy product. And I think that's what Rob's getting at. Yeah, sure, they had to throw away 25% of their product. And when we came in immediately, they did not. That's not a yield gain that we want to claim. You should have been getting there anyway. And there's strategies and cultivation practices that could have got them there too. But then once we got our system installed, it was a matter of analyzing the data, fine tuning again. And that's what got us an additional 20 grams per square foot yield in that space once we were already installed and able to fine tune and look at the data. So just 10. A little bit of 10.
Absolutely. So optimizing the performance of the facility As far as yield increase, we're seeing that revenue increase because we're actually creating an environment that's conducive to our plant's health and production throughout the entire cycle, all year long. Exactly. So no matter what, you give it more consistency and optimize what you're doing itself, you're going to see a revenue increase through consistency of your production, whether it's yield, whether it's cannabinoid profile, or both. You will see that increase in revenue production, like Rob was saying. So that's an excellent question. Speaking of in-rack airflow, like we mentioned a second ago, we have some multi-layer growers here on the line. I have a few questions there. Do you have recommendations for airflow to create a consistent climate across your grow space? Looking at ducted versus horizontal airflow versus vertical airflow fans for an indoor growing environment.
Sure.
Yeah, and then the next question is an LED question, but I'll let you guys answer the HVAC question first on that.
Sure. So if I'm going to try and maintain the conditions of air from a temperature and humidity perspective, the longer I move that air through a process that will either pick up or otherwise lower, through a process that will change the humidity or change the temperature, the longer that air is drawing through the canopy, I'm going to have less control of what those air conditions are. So I would suggest that my recommendation is always go through the canopy in the shortest direction possible, either top down or bottom up. Do not shoot it across the room and hope that the plants that get the fresh air from the HVACD system that are perfectly conditioned, those plants are perfectly conditioned, don't count on the plants at the end of the room being perfectly conditioned as well. So the recommendation always is go through the shortest possible path through the canopy.
Least pass or resistance. Absolutely. We see that, I know this is primarily an indoor question, but we see that quite frequently in greenhouse designs as well too. In commercial agriculture, we've had this whole, we need to have a wet wall. We need to have a wet wall. That's our only mode of cooling everything. And if you have a 120-foot greenhouse, you're pushing that environment across an entire greenhouse, trying to maintain a consistency, right, of a wet wall. And so we think about that, the least passive resistance, the easiest you can create, the easier way that you can create a consistent environment from one end to the other, from one side to the other side. That's where you gain that consistency, which equals increased revenue, right? So the second part of the question with that is, does LED lighting propose a problem with heat by growing that close to the plant canopy, by having in a multi-layer system, having that light itself right above the plant canopy? Does that propose a problem as far as heating?
Yeah, and I'd like to just briefly touch on the first point too. I think just as it relates to lighting and the use of the light that you're providing, the airflow becomes critical because it's tied to the absorption of CO2. So essentially, whatever you do, whatever method it is, top down, sideways, whatever, if you're using high levels of light intensity, you want to be mindful of the plant boundary layer, making sure that you're letting that plant absorb as much CO2 as you're giving or able to give. And you know, when you're talking about high light intensity in general, because I think that there's an industry trend to move with more and more light intensity for new builds, it's absolutely critical to that process. And if it's not addressed, immediately growers tend to start to see problems with the ability to utilize, so to speak, the light that they bought and are planning to use to drive that photosynthetic rate. On the second question, does LED lighting pose a problem with heat by growing that close to the plant canopy? The answer is no, not necessarily, but it's important to note that the heat associated with the LED lighting and with HID lighting is the same per watt. And so if I provide you, let's say, 1,000 micromoles per meter squared per second using 630 watts, that heat is ultimately the same in regards to sensible load. I've just spread it out over a little bit bigger of an area. Therefore, it doesn't feel hot to the touch, but it's still heating my space, 40% less than the HID. HID, you know, in terms of close proximity, is very hard to deploy that because it's meant to be a high bay or installed like a high bay type system. And so, you know, the direction of the heat that's generated by the LED generally moves up because of the heat sink. That's how we dissipate it. That's not the case necessarily with HID. So those are some of the differences, but it's important to note that watt for watt, it should be roughly the same. And I hope I didn't just step on my foot with a bunch of HVAC guys there, but yeah.
Awesome. Hey all, thank you for joining and hanging out with us as we answer your questions. I'd like to shoot off a couple quick fire questions to the team. This one goes to the Inspire team. It's from Dave Myers. Will the reheat BTUs go up when using LEDs because of the lower amount of heat produced as compared to an HPS system?
Sometimes. So the real design criteria that you're going to design your reheat on is just after the lights turn off. Now in both LED and HPS, you've removed the sensible load from the room completely, and you've got these plants that have flywheeled, their transpiration, the stomata are going to start to close. That is the most critical point of dehumidification. I have to account for all the sensible to latent conversion as the water is transpiring at that high rate, just as the lights turn off. And I don't have any sensible to supplement the room with. My HVACD system has got to be able to do all of it. So I don't know if that answers your question, but I don't think the design point is different for either. It's always at that same point when the lights just turn off. And as such, you need as many BTUs in your reheat in one system or another.
Right. No,
Maybe I'm not looking at the numbers, but I think that's where we land when we design these rooms.
Right. This one goes out to Aaron. Aaron, this one's from Andy. Is there a maximum amount of photons that cannabis can absorb during different stages of growth? Meaning, is it possible to be wasteful with light efficiencies that provide more photons than what your plant can actually uptake?
$1 million question. Actually, if you knew the answer.
1.5.
Please give me a call. No, just joking. So yeah, and I'm going to answer that in 3 parts. The first being staging out from flowering down the chain, so to speak. So if I take a cannabis flowering plant, we as an industry don't know yet what the saturation points are. And even if we did, they would probably change genetically, right? So your cookies number 3 and this dude's Blue Dream probably have some different saturation point. And until we've, completely commoditized the crop, we will probably never know. Maybe we will, and it's just going to take us a bit. I will say that 2 people come to mind that are on the forefront. One, again, is Dr. Bruce Bugbee. The second is James Eves, who did a study. I think he's out of Laval. Both have, really kind of pushed the science in that regard. And we have, to some degree, we ran a study in 2017 with Outco, Dr. Alison Justice, and this was when Josh Garavac was head of our horticulture support science team. They ran a study up to 1,200 micromoles, and there we didn't see a total saturation. We see a slowing, kind of curves up, but again, that curve is going to be varied based on your crop and a lot of different environmental factors as well. Optimizing for high light intensity is every bit to do with every other environmental piece that you have in the space, so to speak. So if you start driving really high light intensity in general, you have to be really on point with irrigation, HVAC, airflow, CO2, the whole deal, in order not to just explode and, total crop loss, right? I mean, everything moves at such a fast pace that you have to be able to have the equipment to handle that. So that being said, we don't know on flowering. We don't know on any of it. But if you work your way back to veg, most people in the industry are generally using 500 micromoles average meters squared per second, whatever T5s generate. Historically, we just haven't really cared to put or invest money into that, and we still don't as an industry. So I think that there's a case to be made for acclimating up to your flowering light intensity in veg ultimately. And then once you transition environmentally, lighting, everything, if you diminish all of the transitional piece of that process, that is truly optimizing for flower. And it means that you're at full photosynthetic tilt going into that stage that's critical. Now, where you end up on the PPFD, range in terms of how you go and whatever, I think there is a case to be made for a highlight cultivation and veg. And if anyone wants to run an experiment, hit me up. I'll sell you a couple lights. Cloning, go low, ceiling, you don't need much, right? If your mother production, if you got too many moms, run it low, pull back on the photosynthesis of that, piece of it. Do whatever you're going to do it with purpose, and know that you can't go wrong as long as your environmentals are great.
Right, that makes sense. So to kind of recap that, obviously, like we've said multiple times, really understanding your genetic capabilities is extremely important. And then understanding how your system all reacts to each other and integrates with each other, with the light being the reaction driver. And you have carbon dioxide, water, mineral, nutrients that are all dictated by how much of that light you're giving it, as well as the environment and what the environment's allowing your plants to achieve. That is what is giving you your acceptable light levels. And so the light saturation point, depending on what else you're giving your plant, as well as your genetic capabilities, can continue to rise depending on what the plant's capable of. So another question for the Inspire team. Are your HVACD systems available as a split system, meaning indoor and an outdoor type of unit?
Sure. Yeah, the answer is yes. Absolutely. Our typical construction is good enough for indoor or outdoor. On the air handler portion, we will do things like bolt the condenser to it and call it a package unit. If we have to install it in a tight space, we can do that. Most typically, we have split systems, and also water-cooled systems, and also chilled water, hot water systems, where we don't even have compressors in our units at all. We have a centralized chilled water, hot water plant. So beyond that, we have vertical units, we have horizontal units, we have horizontal packaged. It's a very flexible design. We spent about 1.5 years working with the manufacturers and the factories to come up with our catalog to kind of fit into every one of those niches that we'd been in the previous 8 years. So yeah, check out our catalog. You'll see it there.
That's awesome. We have a couple more quick questions. One goes to Aaron, and it's from Jeff. He asks, during the dark 12-hour period for flowering, does the plant benefit, i.e. carotenoids, by having green light on for 12 hours?
Mute, buddy.
You're on mute, Aaron.
Every darn time. There was two spectral questions, and if this is my last, I'd like to touch on both, and I'll be quick if that's okay. So to Jeff, during the dark period of flower, benefit to green light, I don't believe so. And in fact, depending on your green light, you can actually trigger some rate of photosynthesis. It is low risk, but it's still there depending on how much, what it's coming out of. A green LED gives you a true green nanometer light at a real low efficacy. A green fluorescent, you get into some funky territory. And I'm not saying people shouldn't use green light. I'm just saying I don't know if there's an improvement in your growth and development due to green during the night cycle. I do know that I don't want anything in the night cycle. Blackness, complete blackness every time. And
I've certainly blamed.
Yeah,
Aaron, just to jump in, I've certainly blamed green light at night for hermaphroditic tendencies popping out. It's like,
know.
oh, it's that green light, man. It's gotta be that.
It's not exactly green when it comes out of fluorescence. So if you go buy a party bulb, you're not really working with a true green. You're working with a swath of nanometers. And anyway, so
absolutely.
On the flip side of that, I just want to shout out to green for photosynthesis and the way it drives photosynthesis through additional canopy penetration. And it also allows us to use large amounts of light because it spreads the overall energy across a lot of different receptors that the plant likes. So it's twofold. You got green and white, whether white LED, white ceramic. There's a lot of green in HPS. You want green. The first time you go red, blue on anything, that's limiting your plant's ability to respond effectively at high light levels. And so if anyone tries to sell you a pink light for sole source cannabis, run. Okay, so on that topic, to end this question, changing my screen again to photo oxidation, photo bleaching. This had a question from South Africa. Sean Sangster mentioned using broad spectrum minimizes risk of photo bleaching under intense light, high ppfd cultivation. Can you explain why? I'm going to start with I text Sean while we were in this webinar, and he gave me a different answer than another person I texted. So I think that there's confounding factors to it, and I don't want to be the armchair expert that tells you why. I'd rather you just reach out to Sean. What I will say is that this phenomenon, this was called hash tips back in the day. I don't know if you, this is High Times Magazine. LED grows just hash resinous cannabis. This is not that. This is actually a destruction of the chlorophyll within the plant due to some specific reason. I experienced it while selling pink light throughout the last 15 years when LED was coming to prominence. What I want to point out is that it changes from one phenotype to the next, from one intensity to the next. You'll never get a consistent photooxidation rate, but what that ultimately means for commercial growers, you're never going to get true consistency. And if your market isn't buying hash tips at a premium, then you're taking a hit on it because it doesn't look like a nice quality frosting. Right. Yeah, exactly. And so you cut that out, maybe use it for oil, but still that's your A bud. Don't sacrifice your top quality stuff to get a gain on efficacy. And this is a prime example of choosing your spectral composition based on your environment and what you're trying to produce within the market.
Absolutely. No, that's a great one. And so more science is what I take away from that, right? More understanding of the capabilities of the plant, right? And I as you know, without the full understanding of it, my interpretation is that if the plant is doing something, it's doing something, right? And so if you have a spectrum that is creating a process within the plant, then that plant is active. And so who knows what that activity is doing, whether it could be the cause of the hermaphroditism or whether it's just slowly processing, we don't know yet. But, you know, my take is that if you have enough light to create a process within the plant, then it's doing something. And so might interrupt that 12-hour period in a negative way. So, all right. Well, that brings an end to the Q&A section. There are so many wonderful questions that we would love to answer, but we're out of time, unfortunately. Please follow us on our social channels or email us directly to answer your thoughtful questions. So thank you guys all for the Q&A answers and session. I'm going to shortly bring up contact information.
Is now the right time to thank everyone over at Fluence for working with us on this one today. Appreciate it.
Yeah, it was a lot of fun working with you guys. It was great.
Yep.
Thanks, everybody.
Likewise, guys.
Yeah.
Absolutely.
I'm happy to answer questions if anyone has follow-ups that we didn't get to from the lighting side.
Yeah, absolutely. So we'll get the list of questions and the questioners, and we'll get back to everyone with those answers.
Wonderful. And as you can see here, both of their contact information is on the screen. Remember to visit both Inspire's and Fluence's websites to get alerts on upcoming webinars and events and knowledge to access their resources. Along with Inspire and like Aaron mentioned, the RII, we've also partnered with Agritecture Consulting as part of their digital conference series. Their goal is to educate the controlled environment agriculture industry on emerging trends in crop production. You're going to receive a link to their resource in subsequent emails following this webinar. So one last kind of quick point. We had a question in the Q&A session about joining a coalition of builders and designers to generate best practices for the future. So what a fabulous way for me to introduce the Resource Innovation Institute. Rob, myself, Aaron, and Jesse have all had the ability to contribute towards their free resources on lighting and HVACD that they've put out for free. If you go to the RIA website, you can download both the best practices for lighting guide as well as the best practices for HVAC guide. Incredibly comprehensive. This will give you some really good tools to know and understand to be able to develop your business plan moving forward. It's always better when you come to a manufacturer knowing a little bit of information before. That way you guys can understand what you're trying to achieve together. They're also a great nonprofit organization that provides resources and tools for everyone to be able to use to understand how efficient they are in relation to other facilities of the same type. So with that, I would like to thank you all and hope that you have a wonderful day. Stay safe and healthy.
Everyone.
Take care.
Thanks, everybody.